So this is a new chapter. So basically, this chapter comprises of all the materials which are used for the construction of the road. So your first thing is pavement materials, and it comprises of this chapter comprises of soils and aggregates. So in this chapter we will get to know about different types of aggregates, different types of soils, and their different tests associated with the soils and aggregate. Now, these pavements are a conglomerations of material. Conglomerations means this is a composite of different materials. Now, these materials, their associated properties and their interactions determine the properties of the resultant pavement as your concrete. So, similarly, for the pavement also, as this is made up of different materials, so their combined properties or characteristics determines the properties of the entire road sections. Now, there's a good understanding of these materials, how they are characterized and how they perform is fundamental to understanding pavement. Now, first one is subgrade soil. So, in the pavement, there are different layers. So, what are these layers? Let us discuss. So, this is your soil layer or embankment upon which your pavement is made. Okay, so this layer is called subgrade layer. Okay, this is called subgrade layer. Above this, another layer would be there which is made up of aggregates. This is called subbase. Then another layer would be there which is also made up of aggregate but of the lesser size than of the subbase layer. It is called base layer. And above this, another layer of the bitumen or cement concrete would be there. It would be called your surface layer. Okay, so these are the various component of a cross section of a road, cross section of a bituminous road. So this is the subgrade layer. Okay, that is the below layer of the soil, that is subgrade layer. Now, as all the loads are carried by the subgrade layer, therefore it is very much important so that we take care to prepare or to enhance the properties of the subgrade layer. Now, there are different types of soil like gravel, sand, silt, clay. I am not going about the details of all these things because these things you already know from soil engineering, or your soil mechanics uh, book. So basically, there are different types of soils and their sizes. Okay, sizes of the particles are there. So gravel, these are the coarse materials with particle size under 2.36 mm with little or no fines contributing to cohesion of materials. So these are the different type of materials. I am not going details about all these things. Now, this is important for us. So, test on soil. So, there are different types of test which is applied on the soil for the road aggregates. So, the primary test for the pavement material is California Bearing Ratio Test or CBR test. So, basically, CBR test was developed by the California Division of the Highway as a method of classifying and evaluating soil subgrade and base course materials for flexible pavement. So basically, with the help of this severe test, we get to know about the subgrade strength. Okay, so basically there is would be a severe mold. Okay, yes, this is the severe mold, and this mold would be accompanied with a collar plate. Here one collar plate would be there, that is detachable collar plate would be there. Okay, and in this portion we will place some soil. Okay, that is our material. Now how we place the soil sample? We mix the soil sample with adequate water content so that it can attain the maximum dry density. Okay, that is your optimum moisture content. So basically we will mix the soil with optimum moisture content, and again we will place the soil in the mold in a three-layer format. Okay, and in each layer we'll compact this with 25 number of blows. Okay, after that what we'll do, we'll prepare the sample, and if excess soil sample is there, we will reduce the sample, and over that we will place another plate. Okay, so this is another plate, and in this plate there would be hollow in between the plate. Okay, this in the top view it would be look like this. Okay, so this is called cylindrical plunger. It is called cylindrical plunger. It will be attached with the severe testing apparatus, and the diameter of this plunger is 50 mm. So this plunger would be go through the hole in the plate which is placed over the severe mold. Now there would be two dial gauges attached with the instrument. So this is one dial gauge, and there another dial gauge would be placed over there. Now the function of this two dial gauge is, this dial gauge is required to take the reading of the load, and this dial gauge is required to take the readings of the deflections. Okay, so as the load increases there will be some deflection in the or settlement in the soil sample. So this dial gauge is required to take the note of the settlement. Okay, so after you place the sample and you start loading, you have to take the load values for different type of deflection values. So basically there are different standard deflection values, like first one is 0, then is 0 0.5, then 1, 1.5, then 2, then 2.5 mm. These all are in mm. Okay, then 2.5, then 3, then 4, 5, 7.5, 10, and last 12.5. So these are all of these are settlement values. So against the settlement values you have to take a record of the load value. So for the 0 settlement there would be load value would be 0. Suppose for the 0.5 you get a load value of 2 kilonewton, like that you will get some load values. So ultimately your severe value would be the load values corresponding to the 2.5 mm penetration or 5 mm penetration. So your severe value would be load value at 2.5 mm penetration, that is load at 2.5 mm penetration divided by standard load. There are some standard load values provided by the code. Okay, so for example, the standard load values for the 2.5 mm penetration is 1037 kg. Okay, and for the 5 penetration is 2055 kg. Like that, that is your severe value. Either load at 2.5 penetration divided by standard load, or load at 5 penetration divided by standard load. Now among these, whichever is the larger value will get that severe value. So let us go through it. So severe test and empirical test has been used to determine the material properties for pavement design. Its tests measure the strength of the material and are not a true representation of the resilient modulus. It is a penetration test wherein a standard piston having an area of 3 inch or 50 diameter is used to penetrate the soil at a standard rate of 1.25 millimeter per minute. So this is the standard plunger. Okay, standard plunger, here it is termed as penetrating instrument. The ratio at 2.5 penetration is used as severe. In some cases, the ratio at 5 may be greater than that of the 2.5 So in such cases, you have to can adopt the 5 penetration test as your ultimate severe value. So the severe is a measure of resistance of material to penetration of standard plunger under controlled density and moisture condition. I have told you what is the standard moisture conditions and what is the standard density condition. So to achieve that standard moisture and density condition, we will mix the soil sample with optimum moisture content, and after that we will compact the soil sample with a rammer of 2.5 kg weight, and the number of blows in each layer would be 25 blows. So this is the severe test. This is very important test. So next test is plate bearing test. So this is a plate bearing test. So the plate bearing test is used to evaluate the support capability of subgrades, bases, and in some cases complete pavement. Okay, so severe test is only for the subgrade, but the plate bearing test is essential to know the strength capabilities of subgrade as well as bases, and in some cases that complete pavement. Now data from the tests are applicable for the design of both flexible and rigid pavements. In plate bearing test, a comprehensive stress is applied to the soil or pavement layer through a rigid plates relatively large size, and the deflections are measured for various stress values. So suppose this is the large plate, over the plates you will place some load. So sometimes some sand or some these type of materials are used as a loading parameters for the plate bearing test. So in the plate bearing test, basically there will be some plate, and over the plate you will place some load. Now the deflection level is generally limited to a low value in the order of 1.25 to 5 so that deformation causes may be partially elastic or partially plastic due to the compaction of the stress mass. So here the deflection level which you will control, it would be 1.25 to 5 So you have to place the load in such a way so that a deflection of 1.25 to 5 can be achieved. Okay, and after that you have to take the readings. Now the plate bearing test has been devised to evaluate the supporting power of the subgrades. Now another important aspects of the plate bearing test is this is a in situ test. In situ test means you have to perform the test in the field, where the severe test is a lab test. So these are the two important tests for the soil particles. Now coming to the aggregates. So aggregates is a collective term for the mineral materials such as sand, gravel and crushed stone. So you know there are two types of aggregate, fine aggregate and coarse aggregate. Now there are different desirable properties of the aggregates. So first one is hardness. So hardness is the aggregate used in the surface course are subjected to constant rubbing or abrasion due to the moving traffic. So what happens? Suppose there are aggregate particles adjoining to each other. Okay. Now, if any vehicles move over there, so there will be constant friction between the surface of the aggregate. So this, because of this constant friction, there is chances of wear and tear of the aggregate. Now the aggregate should be hard enough to resist the abrasive action. This action is called basically abrasive action caused by the movements of the traffic. Now the abrasive action is severe when the steel tire vehicles move over the aggregates exposed at the top surface. Now, basically, if we go for the definition of the hardness, so hardness is the ability to resist the abrasion action. Okay, so if with the help of some steel wire or some steel needle, you can mark in some objects. Okay, so that is basically the, in that way you can basically know the hardness properties of any material. Now, in our road aggregate testing, hardness is basically tested by abrasion testing machine, and there are two types of abrasion testing machine. One is Los Angeles abrasion test and another one is Devil abrasion test. So another test is there, Dory abrasion test. So that is not so much familiar like Los Angeles abrasion test and Devil's abrasion test. So in these types of testing machines, what happens? There would be one large drum would be there. So in the large drum, you will put some aggregate along with some abrasive chargers. Now what are these abrasive chargers? Basically some steel balls would be there. So you will place some steel balls in the drum along with the aggregate. So after putting all these things, you just close the lid of the drum, large drum, and after that, this large drum will be rotated. Okay, will be rotated. So when it will start rotating, in that case, there would be friction between the aggregates and between the aggregates and the steel balls. So by this way, some wear and tear would be there. Okay, after that you will after some standard revolutions like 500 times or 1000 times, you will get out of that aggregates with the dust particles because of the wear and tear. You sieve that aggregate with 1.36 ice sieve, and after that you find out what is the percentage of aggregates which crushed under these abrasive charges. So basically that is your hardness test. Next one is toughness. So resistance of the aggregate to impact is termed as toughness. Now what is impact? Impact is the sudden application of the load. Okay, sudden application of the load in an instantaneous time, that is called your impact. Now in the road surface, what happens? Suppose there is a road surface and some speed breaker is there. Suppose one speed breaker is there. So if you drive your vehicle, what happens? Whenever the vehicle cross that barrier, in that case it will create one sudden impact on the road adjoining that barrier. Okay, thus enabling the impact. And another example is whenever the vehicle starts moving over the road, that will also cause some impact on the road surface. Okay, therefore your road's aggregate must be tough enough to resist the impact. So for this we need good aggregate which is very much tough. So how toughness is tested? Toughness is tested with the help of impact test. Okay, so in the impact test what happens, some small type of mold would be there where you place some aggregate, and after putting that aggregate you just keep hammering that portion of the aggregate. Okay, after some standard number of hammering you just find out what is the percentage of crushed aggregate over there. Then another important parameter is shape of the aggregate. You know, in the base course, whatever aggregate is used, they are not used with another adhesive materials like bituminous or some cement. They are not used like that. So only aggregates are used. So these aggregates are kept together with a principle which is called interlocking or interlocking property. Now, to enable this interlocking property, the shape of the aggregate should be good enough. So, therefore, it is very much important to check the shape of the aggregate. Now, the shape of the aggregate is checked with the help of flakiness and elongation index value. So, we will get to know about all this test. Then adhesion with bitumen means how they can mixed with the bitumen. So in this test you put some aggregates and mix some bitumen with it, and after that you find out what is the surface area which is covered with the bitumen. Then durability is the property of aggregate to withstand adverse action of weather is called soundness. Now the aggregates are subjected to the physical and chemical action of rain and bottom water impurities therein and that of atmosphere. Hence it is desirable that the road aggregates used in the construction should be sound enough to withstand all the weathering action. So there are different aggregate tests. First one is crushing test. So in the crushing test, so basically this crushing test is apparatus for the crushing test is your compressive testing machine. For that your where you test your concrete tube. So basically that is your crushing testing machine. So there would be some mold. In the mold you place your aggregate and you put it under your compaction testing machine, and after that you find out what is the portion of the aggregate which is crushed under the equipment. Then your abrasion test. So for the abrasion test, it is what I've discussed already. So there would be a large drum where you put some aggregate along with some abrasive charges and it will keep revolving. After that you find out what is the percentage of crushed aggregate with respect to the total aggregates. Then impact test, the aggregate impact test is carried out to evaluate the resistance to impact of the aggregate or toughness. Aggregate to be used for the wiring course for the impact value should not be exceed 30%. So whatever crushed particle we have found out from the impact test, that crushed percentage of the crushed particle should not be more than 30% for the road aggregate. Then soundness test is carried out to find out any impurities present in the aggregate. Now soundness test is intended to study the resistance of aggregate to weathering action by conducting accelerated weathering test cycles. The porous aggregates subjected to freezing and thawing are likely to disintegrate prematurely. To ascertain the durability of such aggregate, they are subjected to an accelerated soundness test as specified in IS 2386. So you can check details of the soundness test. So basically in the soundness test, the aggregates are exposed with high your cold and high freezing and heating and different conditions, and after that they will find out how much aggregates are sound enough to withstand different adverse weather conditions. Then shape test, there are two types of shape test as I discussed. One is flakiness index and another one is elongation index. So basically the flaky particles are which are thinner particle. Okay, so if you go for the definition of the flakiness index, in that case the definition would be the particles or aggregates which lesser dimension is less than 0.6 times of their mean size. Lesser dimension is basically their thickness. So their thickness is lesser than 0.6 times of their average dimension, that is flaky particles. And another type of particle is elongated particles. So in the elongated particles, as the name suggests, they will be longer. So their length would be 1.8 times more than their average dimension. So this type of flaky and elongated particle you always have to avoid, because they will adversely affect the interlocking properties of the aggregate. The next is specific gravity and water absorption test. So in the specific gravity, you know what is specific gravity. These two tests are performed simultaneously, and water absorption test is also important to find out what is the percentage of water absorbed by the aggregate. Okay, so these are different types of tests, and these are the test methods where you will find it. Okay, there are different IS code. Okay, that is Indian Standard Code, and there are different parts. In different parts of the IS codes, you will get to know about the different properties of aggregates and types of tests. Okay, this is all about today's class.